Module 2, Session 2. Session 2 will cover the following content. Learning Outcome 2.2.2a. Sketch the graphs of inverse functions and obtain the equation of inverse functions given a sketch. Learning Outcome 2.2.2a. Sketch the graphs of the inverse of functions. Sketching of graphs was covered in detail in Levels 2 and 3. The graphing section in Level 4 is not as big as in previous levels. Nonetheless, students do need to be able to draw the following graphs and their inverses. Y equals ax plus q, the straight line graph, or y equals mx plus c. Y equals ax squared, the basic parabola, with x and y intercepts at the origin. And y equals a to the power of x, where a is greater than 0. This is the increasing exponential function. In today's session, we will revise the sketching of each briefly. To sketch a straight line graph, students should recall from previous levels that we can use one of three methods. Method 1. A table of ordered pairs. First, choose some x values. Then calculate the value of the corresponding y values. Then plot these points, and finally, draw the straight line through them. Method 2 is the dual intercept method. The steps in this method are: find the x-intercept by letting y equal 0. Find the y-intercept by letting x equal 0. Then draw your straight line through these 2 points. Method 3 is called the gradient intercept method. The steps in this method are: arrange equation in the form y equals mx plus c or y equals ax plus q. These are 2 ways of writing the same thing. M gives us our gradient, and c gives us our y-intercept. Plot the y-intercept, then use gradient to plot a second point. Draw our straight line through these points. Let's look at an example of a lecturer working with linear functions and their inverses.
Sketching and determining equations of inverse linear graphs. So you are given an inverse function already. The first thing you have to do, you have to find the equation of f of x. So, given y equals to 2 over 6x minus 2. This is an inverse function. So for this inverse function, what you need to do, you need to find the original function of f of x. The first thing we need to understand here is that this can be simplified without tampering or interfering with minus 2. Thus making it, so 2 divided by 2, 1. 6 divided by 2, 3, minus 2. Then, the next step we must understand here is the following. We want the function of x. So, you interchange the position of a of x and y. So, put x here without doing anything on the values or the coefficients, just interchange or swap. Which gives you 1 over 3 y minus 2. What then do you need to do? You need to get y on its own as a subject of the formula. Then you must take x to the other side. You must take minus 2 to the other side. X, so you add 2 both sides to remove this 2, equals to 1 over 3 y. Next thing, you have 1 over 3 y. So you want to remove 1 over 3, multiply by 3 throughout. So 3 times x, 3x, plus 2 times 3, 6, equals to 1 over 3 times 3 equals to 1. 1 times y, y. So what is your f of x? Your f of x is equal to y equals to 3x plus 6. That's number A. Number B. For number B, we're going to use this side, but we must understand that we must sketch the graph of f of x, which is this one. f of x is this one. So we must find one important thing here. We must find your intercepts. So we need to find the x-intercept first. So you need to find your x-intercept. X-intercept is when y is equal to 0. What do we get? 0 as y equals to 3x plus 6. Then take 6 to the other side. Minus 6 is equal to 3x. You want x as the subject of the formula. Divide by 3. Divide by 3. 3 divided by 3 is 1. 1 times x is x. So your value for x, for the x-intercept, x is equal to minus 2. Go back on this equation. You want the y-intercept. So your y-intercept is when x is equal to 0. What does it give you? 3 times 0 plus 6 is equal to 6. That's a y-intercept. Then with this aid of a ruler, you are now able to sketch this function. So you understand that these are your x-axis. These are your y-axis. So label them y, label them x. Identify your intercepts first. So x is cut at -2. -2 is here. And it also cuts at +6. +6 is here. So you can see from here that this is in a form of y equals to mx plus c, where m is your gradient. So your gradient is +3, which means that your function must go on the first and the third quadrant. So it slants to this side. Your function something of this nature. This is -2, your intercept. Then this is +6. You can write them in coordinate form. So what does it mean? It means that x is equal to 0 and 6 is equal, and y is equal to 6. And here x is equal to -2 and y is equal to 0. This is a continuous function, and this is a function of y equals to 3x plus 6. Also, this you can just label as f of x. You must label your function. So this is 0 as the origin, and you have clearly plotted that graph. And just to conclude this, you can be, or you might be, required to plot it in the same axis, in the same system of axis as the inverse, whereby you had a -2 here for your inverse, then you had a +6 for the same inverse. So what do you need to do then? You can plot them in the same system of axis. Definitely can, if required. So what does it mean? It means that this is your inverse function, the one you were given in the question, which is inverse of this f of x. So this is a function of f, and then this is a function, this is the inverse function of that. So you have plotted the function of f of x as well as the inverse function on the same system of axes.
Students should remember how to sketch quadratic functions from levels 2 and 3. In level 4, we only have to work with quadratic functions in the form y equals ax squared. Because this form of quadratic function always passes through the point 0 and 0, the best way to plot the graph is to find a few more points using a table of ordered pairs and to draw the parabola through these. Students should also be familiar with how to sketch exponential functions from levels 2 and 3. In level 4, we only have to work with exponential functions in the form y equals a to the power of x, where a is greater than 0. This form of exponential function always has a horizontal asymptote at y equals 0. The x-axis is increasing and cuts the y-axis at 1. The best way to sketch the graph is by using the table method to find more ordered pairs in addition to 0 and 1. Teaching tip: sketching graphs of inverse functions. In Level 4, students are asked to find the inverse of a function and then sketch it. The most fail-safe way for students to sketch the inverse function graphs is the table of ordered pairs method. Students are far less likely to make mistakes this way. Let's take a closer look at how we sketch inverse function using the table method. First, we find the equation of the inverse function. Second, we draw up a table for x and y values. Third, we choose some x values and substitute them into the equation of the inverse to find corresponding y values. Write these ordered pairs in your table. Next, we plot these ordered pairs from the table onto a Cartesian plane. Lastly, we sketch the graph going through our plotted points. Questions on plotting the inverse of functions are often accompanied by questions about the characteristics of the graphs.
You know, there's a famous question, and really, the learners are highly heroic when they answer that question. It's when they ask the inverse function of the parabola and they put a restriction. We know that if you must find x squared equals to find x, you're going to have plus minus, which covers the positive as well as the negative part of that graph. Now, they put in a statement there. I call it the fine print. The learners must always read the fine print, but they don't read it. They just see inverse, and that's it. No, whoa, stop it. The fine print indicates they only want the negative part. Then you stop and only answer what is asked, or they only want the positive part. Then you stop. So it's advisable to the learners and make it known to them. Read the fine print of that question. Because if you follow the trend of the exams, you will see that's the in thing now. When they ask the question, the inverses of the parabola.
With the next question, we want to find the quadratic equation here. And the question given to us, or the information given to us, is f of x is equal to x squared. So let's look at what the questions are all about. The first question is to draw a sketch of f of x showing the coordinates of at least 3 points on the graph. So, okay, how do we find those 3 points? We can do it using the intercept method, or we can use the table method. I'm going to use the table method because students seems to be much more comfortable with the table method. To do that, right, I do have my table here, so we have our x values and then we will have our y values. So if x, the 3 points, let's use -1, and we have 0, and then we have 1. So if x is -1, then of course my y value will be 1. If x is going to be 0, then my y value is also going to be 0. Then the last one, we have 1. If x is going to be 1, then of course my y value is going to be 1. So now I have 3 points which I can use to plot. Okay? So let's go over let's plot that points. So we have x. If you look at that, x is -1 and y is 1. So I think right up here, right, we can make our mark, right? And then of course we have x being 0 and y being 0, we are right here, right? Okay, and then we have x is 1, it's a positive 1, and y is also positive 1. I think right there we can put it down. Okay, so now we have our 3 points plotted. Okay, maybe I should just give the coordinates, write down the coordinates. So it is, your x will be 1, and you have your y, which will also be 1 right here. Okay, and on the other side, we have x as negative 1, right? And then we have y as 1. Okay, and this one would of course be 0 and 0. Okay, there we have our points. Now just to draw the graph itself, sketch it. Okay, so let's see. All right, going down. And there we have our sketch of the quadratic equation. It's also called the parabola. Some of you might pronounce this as parabola. Okay, so now we have the sketch. I think that would satisfy the first questions. Draw the sketch of f of x showing the coordinates of at least 3 points on the graph. Now, let's go to the next question, which will be determine the inverse, okay? If f of x is restricted, restricted to the domain x is greater than and equal to 0, and the range y is greater and equal to 0. So when we look at that, we can see there's going to be a restriction inside of that answer. Okay, now we have to determine the inverse of f of x, and there's a restriction inside of that. So okay, let's see. Remember what we said. We with finding the inverse, we change our x and y values. Now, what was given to us was f of x, right, which is equal to x squared, right? This is the same as y is equal to x squared. Change our values, so this becomes x is equal to y squared. Right, we do not want y squared. Let's get rid of that y squared, and of course, right, we know we have to use the square root sign, so this would be square root sign x, the square root of x is equal to y. Now, look at this. We have, remember, we have a restriction. We have a restriction. And that restriction says that it is going to be x is going to be greater and equal to 0. That's our restriction. Therefore, we are only going to use the positive. It is greater than 0. X is greater than 0. So we're only going to use the positive and not the negative. So please make sure that you explain that to your students. Because of that restriction, we are only going to use the positive sign, not the negative. Okay, so that would be our inverse. Okay, right. So we have that. We have determined the inverse. I think now they want us to number 3. They want us to sketch the graph of the inverse on the same set of axes. Right. What I normally would tell the students is just change your x value. Remember, to find the inverse, we have to change the x and the y value. So instead of having x here, this become my y value, and the y value becomes my x value. So now I'm going to plot it. Now be very careful with your very first coordinates. Remember there's a restriction, and the restriction says that x is greater and equal to 0. So we're going to leave out the very first coordinates, and we're going to start with plotting down 0. In the second, y is equal to 0 and x is equal to 0. So we plot it down again, and then we have y is equal to 1 and x is equal to 1 right over there. So you can see, let's just draw that quickly. Right. Now, remember, if we have used the first one, it would have been going that way. Right. But because we have that restriction, we stop right here at 0. We have to make sure that the students do understand it, because in most cases when they write the exams, they would draw the whole inverse and they do not use the restriction that has been given to them. Okay? Right, so that would be the sketch of the inverse. I've just drawn the dotted lines just to show you what the inverse would have looked like, but because of the inverse, right, we stop right at 0 and y is equal to 0 and x is equal to 0. Okay, so we have now sketched number 3, the inverse on the same axis. Let's look at question number 4. Write down the domain and the range of the inverse. Very important. We are now looking at the inverse graph, the graph of the inverse. So if we look at, first of all, when we speak about the domain, we talk about all the x values. And when we speak about the range, it's all the y values. So when we look at the inverse graph, the domain, right here, the domain, you can see that we have right up till 0, we have all the x values, but it does not continue into the rest of the other negative x values. So what can we say? If we look at the domain, right, it's x is you can say x is all real values, right? But here we have, because of the restriction, and we start off with that sign, which is, it is from 0 and it will go right into infinity. So that would be our domain. Is that good? So when we look at the range itself, what do we have here? With the range, we are looking at, right, now remember this is all your y values, So when we look at that, it also, with the range, the restriction also starts with 0, and it will give us, it goes right into infinity. And you see it will continue right up into infinity, but we have a restriction right here at 0. Sorry, this is wrong. This should not be. That should be that, and that should be that. Okay, right. That is now question number 4.
We will now pause the video to do a group activity. In your groups, have a discussion on teaching inverse functions. What is your approach? Any problem areas or tips and tricks? After your discussion, work through part B on an exponential function and its inverse, thinking about how you would teach this to your students. Let's watch a lecturer working through the solution to the problem.
Okay, let's look at the next question. Within the next question, they ask us to sketch the function f of x equals to 2 to the exponential power of x, and find and sketch the inverse of the function on this on the same axis. Okay, right. So what do we have here? Yeah. Okay. Let's use the table method once again. We have x and we have y. Right. So let's look at it. Let's use the points. We have, let's go for -2. We've got 0, we've got 1, and we have 2. So if x is -2, we know that our answer will be, the y value will be 1/4. If x is 0, then the y value will be 1. If x is 1, then the value will be 2, the y value will be 2. And if x is 2, the y value will be 4. Right. Okay. So let's quickly look at sketching that function. So we say if x is -2, then y will be 1/4. Well, I think that would be 1/4 right there. And then if x is 0, then it will be 1. Y will be 1. And if x is 1, y will be 2. Right over there. And if x is 2, then y will be 4. Okay, so let's just join that right over there. So this will be f of x. This is 1 and 4. This will be, sorry, this is 2. And this will be 1 and 2. Right, this will be 0 and 1. And this one will be -2 and 1/4. Right. Okay, so there we have the function. We have sketched that function, and I think we can let's just look at finding the equation of the inverse. Remember, we changed our x and y values, so we have f of x is equal to 2 to the exponential power of x. This is the same as y is equal to 2x. Now change the values. This will be x is equal to y, and you remember we leave it like that. Okay, right. So let's go to the second question. We have to sketch the inverse as well. So we're not done with question 1. So let's sketch the inverse. Right, with the inverse, what we said is, let's just change those. Right, and then we have y is equal to -2 and x is 1/4. So right up here, I think that would be good. Then we have y is 0 and x is 1. So that would be the next point. And then we have y is equal to 1 and x is 2. So it will be right over here, right? And then we have y is 2 and x is 4. So that one will be right over here. Okay, let's just try and connect those dots once again. Coming down. This is function. X is equal to 1 over 4 and y is equal to minus 2. Here we have y0, x1 and y0. Here we have x2 and y is 1. And the last one would be x is 4 and y will be 2. Right. So there's all. I think we are done with sketching the function as well as the inverse on the same axis. So question number 2 is give the equation for any asymptotes, right, for the function and its inverse. Okay, right. So when we look at the function that we have here, f of x is equal to 2x. As you can see from this function itself, that we do not have the c value, meaning that where the asymptote is going to cut, the y value will be at 0. So we know that y will be equal to 0. That will be, if we would give the equation of one of the asymptote for the function itself. If we want to find the asymptote for the inverse, right, then it will be x. This is question number 2. Question number 2, x is equal to 0. Okay, so that will be the equation for the asymptotes for the function, and that will be for the inverse, right, because here x will be equal to 0. So let's look at question number 3. But question number 3, right, is the inverse a function? Is it increasing or decreasing? So question 3, right, we can put it on this side. Is the inverse a function? If one would take a vertical line and bring it across here, you will see that it only cuts the graph once. So we can say, yes, it is a function. Okay, it is a function. Is it increasing or decreasing? As the x values increase, the y value, as the x values increase, the y values is also increasing. So yes, we can say it is increasing. Right? The function is increasing. The inverse function is increasing. Let's look at number 4. With number 4, we want the range and the domain of both the function and its inverse. Okay, right, let's make this number 4. Let's look at the domain and the range. Let's first look at the domain, right? So when we look at the domain, remember the domain is all x values, so we can see that it's all real values. So x is equal to all real values, so we can say x is an element of all real values. Right, and then we look at the range itself. With the range, we are looking at the y values. Now, if we look at the y values, can you see the y values never touches the x axis, right? So there's kind of a restriction there. So we say it is right from 0 to infinity. Okay, so that's your domain. X is an element of all real numbers, and the range, we see there's a restriction. It never touches the asymptote. So we say that y is equal. It's not equal. Y is greater than 0. If we look at the inverse itself, with the inverse, look at the domain. The domain, the inverse function, all x values. Let's look at all x values. Can you see it doesn't go over to, so there's a restriction over here, so we can say it is 0 and it goes into infinity, right? And then the range, if you look at the range, can you see right over y values are included? So we can say y is an element of all real numbers. Right, so did we complete that? Yes. We have the range and the domain of both the function and the inverse.